Okay, so we are on lesson 3 of the International University of Management Quantitative Methods 1 course. And today we are looking at measures of central tendency. Now, what is a measure of central tendency? Well, the measure of central tendency, that's one number that can pretty much describe your whole data set, or one number that best does that. Now, there are three types of measures of central tendency, and you all know those ones. It's the mean, the median, and the mode. Now the mean, that's one we learn from when we were little kids. We work out the means or averages of certain things. Or maybe I was just a little bit strange, but watching cricket matches or anything on TV, I'd take my mom's 3-column book for accounting and work out some stats for all the players as I was watching them in every series. But suffice to say, I think we all know what the mean is. The mean is the average. How do we calculate an average? We add all of the data points together and divide it by how many data points there are. So an example could be you have these three, well, let's make it like that, right? We've got these numbers. I want to find out what is the average of these numbers. Right, so how do we find that? Well, we just say we add all of them together, 3, 4, 5, and 6, and then we divide that by how many numbers there are. 1, 2, 3, 4, 5 numbers. That'll give us the average of these numbers. So let's quickly do that. 3 plus 4 is 7, plus 5 is 12, plus 6 is 18, plus 7 is 25. So we get 25 divided by 5, and that gives us 5. So that is the mean. Now, the median, that's the number right in the middle. If you take these numbers and you arrange them from small to large, now in our case they are already arranged from smallest to largest. Once you have this, and then you pick the middle number, the number that has an equal number of items to the left and to the right of it. That will be our median. So in this case, we can see that's going to be 5 because it has 2 numbers to the left and 2 numbers to the right. So in essence, the 5 splits the data into 2 equal parts, a smaller part and a larger part. So that's another measure of central tendency. And the mode, well, that's just the number that occurs the most. All right. So let's say if we edited this, let's just edit the set slightly, and maybe let's do, I'm just gonna erase these values and just redo them just with a slightly different set so we can actually have a mode as well. But the thing will stay pretty much the same. So we're gonna have 3, 4, but then 5, 5, 5, 6, 7. Okay, so to find the mean, again we just add all of these. Now if we add all of those together, we just added 2, 5, so that's another 10, right? So that's 7 numbers, and that'll be 35 then over 7. That gives us 5. So that's still our mean. Now for the median, let's do that again. Write all the numbers down. 5, 6, 7. So now we have 1, 2, 3, 4, 5, 6, 7 numbers. And again, we can pick the middle one. That's the median. We arrange it from small to large, pick the middle one. It has 3 numbers to the left and 3 values to the right as well. So 5 is the median. Now what about the mode? So the mode, that is the number that occurs the most common number in our set. And in this case, we can see there are 1, 3, 1, 4, 1, 6, 1, 7, but 3 5s. So 5 here is our mode. So you can see, depending on the data set, but if we get a large enough data set, and it follows a sort of a normal distribution, like the bell curve you'll know, then the mode, the median, and the mean will all be pretty much in the same spot. Right? And if they're not, it also tells us a lot of interesting things about the data. If you have median, or like mean, mode, median, or just the other way around or something, that tells you a little bit about the data, which thing goes where, which thing is bigger than the other. But in general, all three of these should be a pretty good representation of your data. So if this was, let's say, marks out of 10 for a test, then what can you say about your tests, those last 7 tests you wrote? Well, you can say you pretty much got 5 for them, right? So that's an average that you got for them. That's the median, so half of them were lower and half of them were higher than 5. And it's also the most common one. Most of the time you got 5, and it averaged 5. So a measure of central tendency, that's just one number that can describe the whole data set. Okay, and all of these were pretty easy, but in this lesson we'll be looking at grouped data as well. For ungrouped data, that's what we did here, and we'll do 1 or 2 more examples as we get there. So this is the formula. All this says is x bar. So x bar, that's just the symbol for mean. So x bar equals, Now what does this thing mean? That's just the capital S in Greek called sigma. Now sigma we always use to mean sum of. So it means we're going to add everything to the right of this together. Okay, so xi, as soon as we have an xi, that little I just means we've got different x's. So in our case here, that would be x1, that would be x2, the second value, x3, x4, etc. So for what xi means, we're just summing all the xi. So we're summing x1 plus x2 plus x3 plus x4, etc. Adding all of those together, divided by n, then number of things. Right. And for group data, we'll get to this. So it's pretty similar, but these two things just mean slightly different things. Where fi, that's going to be, what do we call that? That'll be the frequency in the class. And this value, the xi, that will be the midpoint of our class. Right, but we'll get to them and we'll see. But in essence, it works the same. It just takes a little bit more work. Examples. Okay, given the following marks, find the mean mark. All right, let's do this in pink. So the mean, how do we find the mean? Again, we just add everything together, add all of them, and divide it by how many things there are. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. Okay, let's add it together. Let's see if I can do this in my head. It has 35, 80, 98, 105, 115, 145, 153, plus 1265, I think. I'm not sure. You can test on a calculator. Actually, I do have a calculator here. Let's use this. Let's see what it gives us. Apologies for the slow working. 20 plus 15 plus 45 plus 18 plus 7 plus 10 plus 38 plus 12. That is 165. Good one. Divided by 8. So we just say that, divided by 8, and we get 20.625. 20.625. So that is our mean, or our average of all these marks. Okay. Good. Second question. For the past 10 years, a company has declared the percent dividends as follows. In year 1 it was 5%, year 2 6%, etc. Okay, so calculate the mean. So all this is either just 10 numbers and we have to find their average or their mean. So again, we just add all of them together and we're going to divide it by how many of them there are. Okay, so these values added together, divided by, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that gives 11, 25, 45, 75, 85, 100, 120, 140, 170 over 10 equals 17. There we go, that's our mean. Okay, median. Okay, so for median, we have to arrange the data set from smallest to largest. Then we have to find out if it's even or odd. So this part here, this is interesting. Not all courses make a distinction between even and odd in this way. But since it's here, we will do this. Okay. So we arrange the data set, we find out are there an even number of things or an odd number of things, because that will influence our formula for finding the position we're looking for. All right. Then we find the position of the median by applying this formula. And then we just read off the value at that position. Okay, let's go through this one. So we want to arrange it from smallest to largest. So the smallest value we can find here is a 7. Next smallest is a 10, it looks like. 10, 11, 12. Any other 12s? No. 13, 14, 15. 15 is the next one. 16, 17, 18. Then 19, 20. 25, 38, and 45. Okay, so now we've arranged it from smallest to largest. Step 1 complete. Let's mark that. Step 1 complete. Now identify if it's an even or an odd set. How many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, let's just count again to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 values, so that's odd. We're going to be using that formula to find the position. So our position, the position of the median, is going to be n, which in our case is 9, plus 1 over 2. That gives us 10 divided by 2, which is 5. So that tells us in the 5th position. So 1, 2, 3, 4, 5. So there we go, the fifth position. So our median is 18, which means half the values are less than 18 and the other half is more than 18. Good, so that's the median. Now you can do this yourself in the next one. I'm not going to do another example which is exactly the same, but hopefully you get the idea. Let's just count this one. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case it's 10, it's an even number, so we just use that formula to find the position, right? Just n over 2, not n plus 1. For odd we use n plus 1. Okay, like I said, that's not the same in all cases. If you learn something different at school, don't worry, just follow this method. There are lots of different methods people can use, and just use the one you get taught in the course. Then mode. Mode is the really easy one. You just check which number occurs the most, right? So that's going to be 10, because there are 3 tens. And everything else is sort of just once, not even twice. So the mode is 10. Perfect. Okay, so that's mode, median, and mean for ungrouped data. Now we're probably going to get to group data. There we go. Okay, and like I said, we'll talk about this. This is the one we had for ungrouped. For group data, we're going to be using this idea. Now it looks a little bit more complicated, but it isn't really. I'm just going to change colors for this one. Let's do, what do we do? Let's do orange. Okay, so we said the fi, that's going to be the frequency of the class. And a couple of videos ago, we looked at different classes, right? If you do a frequency table, you've got, this could be your class, and it could be like something like 0 to 10, and then 11 to 21, or something like that. Here you have your classes. So the frequency and then how many things are in this class. Maybe there were 5 things in this class and 6 things in this class, in that interval, right? So that's going to be, this is your frequency. Then the xi is the midpoint. So xi, I'm just going to call it midpoint. So the midpoint, what is halfway between your starting value in your class and your ending value? So the easiest way to do that, I mean, in this case we can see it's probably going to be 5, right? Because 5 looks like halfway between 0 and 10. Just to clarify, the easiest way is to take the smallest one plus the largest one, or lower limit plus upper limit, divided by 2. So 10 plus 0 is 10, divided by 2 is 5. So your midpoint is 5. And the same here, between 11 and 21, add them together, divided by 2. So 11 plus 21 is 32 over 2, and that gives us 16. So 16 will be the midpoint here. But we'll get to that in examples as well. That just gives you an idea of what is the frequency and what is the midpoint. Frequency, how many things in the interval. The midpoint, the halfway value between the lower limit and the upper limit. Alright, and this, we say it just means sum. It's just a capital Greek letter S. Alright, good. So here, they ask us to calculate the mean for this. Alright, so I'm just going to draw a few extra things in here. I'm going to add 2 columns. Okay, so let's make it roughly halfway and continue drawing our lines here. Apologies for a little bit of time taking, but I think it looks quite nice if we draw the extra columns in. Alright, now the names, so this will be our frequency, and this will be our midpoint. Great. So the frequency, well, actually we have frequency already here, right? So we don't need that. We don't need that. Let me erase that. What we do need, this will be our midpoint. We already have our frequency, but then we need our frequency multiplied by our midpoint. Right, so multiply those together. Okay, to the midpoint, halfway between 10 and 12 is 11. Now this is nice because this is pretty straightforward. We can see what the midpoint is. That's 11. This one's going to be 14, 17, and 20. Right, and just to make sure, let's pick this one as an example. We can say to find the midpoint 16 plus 18 divided by 2. That gives us 34 over 2, which is 17. So we see our intuition was correct. Now we do the multiplication. 4 times 11, 44. 12 times 14, what is that? 144 plus 24, 68. 168. 20 times 17, 340. And 14 times 20 is 280. Great, so that was that's the hard work for this question, and you see it's not even that hard. Now all we do is we add all of this. That's where the sum formula comes from, right? The sum of our fi times xi. So that is this value here. And the sum of our n, or n equals 50, they just give it to us, so n equals 50. That's that value. Okay, add all these together. Let's do that on the calculator. 44 plus 168 plus 340 plus 280. So that's 832. 832. So the sum of fi times xi is 832, and n is 50, and then we just divide that answer. So divide by 50, 16.64. That's it. That's all there is to calculating the mean for group data. You have your classes or intervals, you have your frequency, then all you do is you find your midpoint of the class, and then you multiply frequency by midpoint to get each value here, add all of them together. So maybe do this. So add all of this together to get that, and divide it by the total number of things. There we go. So that's mean. So still mode and median to go. Median first up. Okay, now we can see this looks a little bit more interesting, right? The formula here. What I'm going to do, let me just copy, well, actually before I do that, so we can still see it. Okay, now let's read what they say. Firstly, identify the median class. So the median class, that's which interval in our table, like if we had this table here, which of these classes or intervals includes the median. That'll be important. Okay, calculating the value of n over 2. So n is the sum of all the frequencies. So the number of things you have divided by 2, that will give you the position of the median. And then see in which cumulative frequency column it falls. We've already looked at cumulative frequency, I believe. But if we haven't, we'll cover it again as we do the example. Find the first value greater than the result of n over 2. And we'll see why that is. We'll try to get an intuition of why that works. Then the corresponding class interval is called the median class. Okay, then we apply the formula. Now, let me just, I'm going to write this down and copy this formula so we can use it on the next page. Plus big bracket, n over 2 minus big F over Fm, close bracket, and I. So I'm just going to copy this bit here. Right, and let me paste it over here so long. We'll be using that formula. Great. Now, so this is the thing we have to use to find our median value. Now what is Lm? Okay, so let's find each of these individually. Lm, let's read what they say here. That is the lower boundary of the median class. The lower boundary. Okay, now, so again, we see they use the word boundary here. I'm just wondering if it should be boundary or limit. I think boundary is correct. Let me just see. So it doesn't actually matter. We can just see what they use for the mode. Do they also use boundary? Lower boundary, yes. Okay, that's perfect. Okay, so we'll just use boundary. So the lower boundary of the median class. So firstly, let's draw a few more columns, or just at least one more column. And we're going to use that to find what is the median class. Again, this column will be the cumulative frequency. Cumulative frequency. Okay, so cumulative frequency, that just tells, we're just saying we're accumulating the frequencies. So adding them together. So the first one is 8. So the cumulative frequency, this just means 8 values are between 1 and 10. Then we add 14 to it, the next value, that gives us 22. So what does this 22 mean now? That means 22 values are between 1 and 20. So it includes both of these classes now. Then we do the same thing, add 12 to that, 34. So again, that means 34 values are in these three classes. And we just keep going. 34 plus 9, 43. 43 plus 7 is 50. And then you can check, the sum of the frequencies must be the same as your last cumulative frequency value. If those are the same, then you have counted correctly. Alright. So now to find which of these classes, 1, 2, 3, 4, 5 classes, is the one that contains the median. Well, we know n is 50. So we can do n over 2. n over 2, which means we've got 50 over 2, that gives us 25. So the 25th value, arranged from smallest to largest, like this is, right, from small to large, the 25th value will be our median. Okay, so we see 8 values are in between here, so the 25th value cannot be in this class, right? So that one's out. Then 22 values are in these two classes together. The 25th value cannot be in any of these two classes, so those two are out. 34 values in the first three together. So in the first three together, the 25th value must be in there, but it cannot be in these two, so it must be in this one, right? So that's sort of the intuition of why we say we look for the first value in the cumulative frequency column that's larger than 25. So 8 is smaller than, 22 is smaller than, 34, yes, bigger than. Great, so that means this is our median class or median interval. Great, so now we know this, we can complete the rest of the question. So this is, like we said, the lower boundary of our median class. So remember what boundary and limit, what's the difference between those two? The lower limit is the smallest value you see, and the upper limit the largest value you see. But for lower boundary, we subtract 0.5. If it's not exactly the same as that value, we subtract 0.5 here. So 21 minus 0.5 is 20.5. That's the lower boundary. The upper boundary here would be 30.5. Great. So that's lower boundary, LM. What do we have next? We've got the F. That is the cumulative frequency before or above the median class. So F, cumulative frequency before we get to this class. So before we get to 34, the cumulative frequency was 22. So F is 22. Then we have our FM. So that's the frequency of the median class. So what's the frequency? Our median class is this one. What's the frequency? 12. So FM is 12. Good. So we've got the LM, we've got the F, we've got the FM, and we still need the I. The I is the class width. So here one. Okay, this doesn't really look like an I. That should be a nice I. That's the class width. And the class width, that's just the difference between upper and lower bound. So I equals, in this case, I mean, probably in all the cases we're going to see all the class intervals are going to be the same width, right? Because that's quite a nice way to represent data. It might be in some real life scenarios where they won't be the same distance apart, the same width. Then you'd have to think about that. But for our purposes, all of them will be the same. Like you can see 10 minus 1 is the same as 20 minus 11 is the same as 41 minus 33, exact, etc. So our class width is 30 minus 21 or 10 minus 1, same thing, that's 9. Great, now we can just plug this in the formula. So our mode, no, we're at the median, my apologies, median. So the median equals LM, so that's 20.5, plus n over 2, so n we know is 50, so that's 50 over 2, minus f, 22, which is the frequency, cumulative frequency before the median class, so minus the 22, over fm, the frequency of the median class, which is 12, and then we multiply that by the width of the class. Okay, let's work this out. 20.5 plus 50 over 2 is 25, 25 minus 22 is 3, 3 over 12 is the same as 1 over 4. Multiply that by 9, we get 9 over 4. So 9 over 4 is the same as 2.25, if we want to write it in decimals. So then we get 22.75. So there we go, that is our median. So you see, it's not too bad. Just take this. Now what you would need to do, you need to spend a bit of time studying this formula, just so you get used to what everything means. But you'll see pretty shortly you won't even need these symbol names anymore. You just know exactly you need to put that value plus that value over 2 minus that value over that times the width. And that'll become pretty much second nature pretty soon if you just practice that a bit. Here, let me just get rid of this. Alright, so we just apply, plug and play. Formula, plug and play. All we needed to do was add the cumulative frequency column. Right, and the last one for this lesson is the mode. Very similar to the median idea. And what color we'll do this one in? We'll do this one in red. Okay, so we see, again, very similar type of formula. So I'm going to again copy this so we can use that on our next page. Bracket delta 1 over delta 1 plus delta 2. So delta, again, that's just the capital Greek D and I. Good, let's copy that one and paste it on the next page, or not next page, but close. Right there. Perfect. So again, we're going to be using a cumulative frequency here. Do we need that? I is the class width. Delta 1 is the difference between the frequency of the mode and the frequency of the class before that. Delta 2 is the frequency of the modal class and the frequency after that. And then Lm is the lower boundary. So we don't even need a cumulative frequency curve here, or a cumulative frequency column. So let's find our values. So Lm, what do they say Lm is? Lower boundary of a median class. Okay, they mean modal class. Lower boundary of the modal class, since we're calculating the mode. Okay, so what we need to do, which class is the mode? Okay, so maybe this is something you probably won't need because we said the class widths will be the same in every case. But maybe this is useful to use somewhere where the class width aren't exactly the same, like in your job somewhere maybe. Let's check. So this column will be the frequency density column. Frequency density, and that's actually what we use to find the modal class. But in this case, like I said, it won't be a difference. It'll be exactly the same ranking as the frequency. But let's just do it because I think this is important and it might be useful to some people in their work scenarios. Frequency density. So the density is just you take the frequency divided by the class width. So in this case, 8 divided by 9. So that's 0.89. Round off to 2 decimal places. Then 14 divided by class width, and this is again 9. So that is 14 divided by 9. That's 1.56. 1.56. There's density 12 divided by 9. So 12 over 9, 1.33. 1.33. Then 9 over 9 is 1. 7 over 9 is 0.78. Right, so we can see. So now we look for the biggest number here. That'll be our modal class. So 1.56, that's the biggest one. That's our modal class. But like you can see, the ranking is the same. Because these widths are all the same, we can just look at the frequency. We don't need the frequency density. If these widths are different, then please remember to add a frequency density column and work that out. All right. Good. Now let's get back to our formula. So Lm, that's the lower bound. Let's actually use an equal sign. Equals. That's the lower boundary of this class. Lower boundary is 11, but there's a gap, so we subtract 0.5. So 11 minus 0.5 is 10.5, lower boundary. Lower limit would have been 11, so make sure you get your definitions right. Delta 1. So delta 1, well, delta, you all know, delta usually means difference between. So let's see what they say. Delta 1, that's the difference between the frequency of our modal class and the frequency of the class before that. Okay, so difference in the frequency of our modal class and the class before the modal class. So 14 minus 8 is 6. Good. Delta 2. That's the difference between the frequency of the modal class and the frequency of the class after the modal class. So 14 minus 2 is 2. And then I, that's our class width, and we saw that's 9 for all classes. Now all we do is we just plug it into the formula and solve. So Lm 10.5 plus big bracket delta 1, we said that's 6, over delta 1 plus delta 2 multiplied by the class width. So 10.5 plus 6 over 8 is the same as 3 over 4. 3 over 4, multiply that by 9, so 3 times 9 is 27. Okay, so 10.5 plus, what is this? This is 6.75. And then we can add them, so 10 plus 6 is 16, plus 1.25, 17.25. Great, so that is our mode. Perfect, and you'll also see this value will maybe I shouldn't say always, but I'm going to say it anyway. This value will fall inside your modal class, or the class we're looking for. So if we're saying this is the mode, then it must fall in the modal class. Let's just go back here with the median and see if the same thing happened. So our median class between 21 and 30, this is between 21 and 30. So we see it falls in between there. So that's a good idea. If it falls somewhere way out here or something, then you know something went wrong and you can recheck that. Alright, so that is it for this lesson, lesson 3. Next lesson, we'll be looking at measures of dispersion, lesson 4. I'm just going to write in lesson 4 here. I think that's missing on my page. Lesson 4. Measures of dispersion. Okay, I'll see you shortly for that one.